Okay, good morning class. So at this point we're looking at analytical geometry. We are busy with exercise 4.5, correct? So we completed 4.4. So that page I can delete. Hello! People make a noise, man. Okay, so you haven't done this question yet? No. Is that where we stopped yesterday? Okay. Then I gave you homework on 4.5. No? Or is it 4.6? 4.6. So now we're looking at example 3. And it's on page. Which page is this on? 102. Okay, so the question says in the diagram A is the point 0 and 5. A is the point 0 and 5. B is the point 8 and 5. The equation of AC is y is equal to negative 2x plus 5, whilst BC is y is equal to 2x minus 11. Okay, so the question, and further on we are told that AC and BC intersect at C. Okay, so the first question says, determine the coordinates of C. Determine the coordinates of C. Alright, so how do we calculate the coordinates of C? How do you calculate the coordinates of C? Yes? Sorry? The wrong question. Never mind. People, we got the equation of AC and we got the equation of BC. Yes. Simultaneous equations. So, for C, we're going to say negative 2x plus 5 is equal to negative 2x minus 11. Simultaneous equation. You see the two graphs equal to each other. Whoops. Problem, I think this equation is wrong there. So otherwise your x's will cancel out here. Not so? Yep. Can you see that thing is wrong? So this is supposed to have been positive too. Okay. So let's solve for x. We're going to get negative 4x is equal to negative 16. So x is equal to 4. So the x coordinate of C is 4. How do we calculate the corresponding y value? By substituting 4 either into the equation of AC or in the equation of BC. It should give you the same answer. So 2 times 4 is 8 minus 11 is negative 3. So y is equal to 2 times 4 minus 11, which is negative 3. Therefore C is 4 and negative 3. Okay. Let's see the next question. People, I would need the space here. So I need to take this off. B says, calculate the size of theta, the inclination of the straight line BC. Let's calculate this angle theta. The inclination of line BC correct to 1 decimal place. So what do I need in order to calculate the angle of inclination? I need the gradient of BC, not so. So what do we say? Tan of theta equals the gradient of BC, which is 2. You all agree with that? So arc tan of 2 gives us 63,435. So 63,4. The next question says, show analytically that AC is equal to BC. So if it says by analytical methods, or by using, by showing it analytically, that means I must use the distance, or the gradients, or the midpoints, or things like that. You guys understand? So, what are they referring to if they say AC is equal to BC? What are they referring to here? The length of AC and the length of BC. Not so? So what do I do here? I work out, so this is not B, I work out the length of AC. How do I do that? Distance formula. So it's x2 minus x1 squared plus y2 minus y1 squared. For AC, it's going to be 5, so it's the square root of 5 minus minus 3. So it becomes 5 plus 3 squared plus 0 minus 4 squared. Okay? So that is square root of 5 plus 3 squared plus 0 minus 4 squared. Gives us 4 root 5. Okay? Let's look at BC. Remember the question is show that, so I can't use that in my proof or in my calculation. So for BC, same story. There's B and there's C. So it's going to be x2, so it's 8 minus 4 squared plus 5 minus minus 3 squared. Okay, so again, that gives us the square root of 8 minus 4 squared plus 5 plus 3 squared. Or I could have just said 4 squared plus 8 squared. Okay, it's going to give you 4 root 5. So what do you notice here? What do you notice? They're the same. So in conclusion, I say therefore AC is equal to BC, which is equal to 4. Okay, you guys agree with that? So 4 root 5, this is 4 root 5. So they are equal in length. Okay, you all okay with that? Alright, let's look at the next question. This is D. D says, determine the coordinates of P, the midpoint of AC. How do you calculate the midpoint? Midpoint formula, not so. So, the midpoint, which is P then, the point P, the midpoint. How do you calculate midpoint? It's x1 plus x2 over 2, y1 plus y2 over 2. You all agree with that? Alright. So remembering, that is x1, this will be y1. So it's going to be P, it's going to be 0 plus 4 over 2 and 5 plus minus 3 over 2. Which then gives us 2 over 2, which is 1. And 2 over 2, which is 1. Does that make sense, people? The way it's situated? Yes. Okay. So in the first quadrant, x positive and y positive. Let's look at E. Determine the equation of the perpendicular bisector AC. The perpendicular bisector of AC. So in other words, a perpendicular bisector, that line, that is that line that I've just drawn in. What does perpendicular mean? It stands 90 degrees to AC. And bisector means it cuts in half. So you all agree that's the line I'm calculating. So the perpendicular bisector, and the gradient would be what? You know, the gradient of AC times the gradient of this perpendicular bisector will be -1. Why? It's perpendicular. If the lines are perpendicular, the product of the two gradients is -1. You all understand it? So, the gradient of AC is -2. So what is the gradient of the perpendicular bisector? Half. Yes. So my equation is y is equal to a half x plus c. So how do I calculate c? I substitute, yes? A point that lies on that line, yes. Do we have a point that's lying on that line? Yes. Which is what? P. It's going through P. Why? Because P is the midpoint. It's the bisector. Not so. It's the point at which is cutting in half is bisecting. So you're going to substitute P, which is 1 and 1. So remembering that's an x and a y. So 1 is equal to a half times 1 plus c. So what is 1 minus half? The equation is y is equal to a half x plus 1. Okay. Is that correct? Yes. Is that wrong? Okay. So the gradient is off. Yes, okay. Is P right? Just check if P is correct. The coordinates of P? No. Oh, that is 2. That's my mistake. It's 2 and 1. So it's 2 there. So that x is 2. So that's 1. So it's 0. C is 0. So C is equal to 0. Y is equal to half. Sorry about that. Any other confusion? Okay. Let's check the next question. Isn't there another example? No. No. Okay. Then I asked you to do 4.6 to odd numbers, correct? Or did I ask you to do the whole thing? The whole thing? Odd. The whole thing or the odd numbers? Okay, so I'll see how much of these sums you can answer in the remainder of this lesson. So we're looking at exercise 4.6. So on page 106, no? 103. 4.6, page 103. Right. So we are told that in the diagram, A is the point. A is the point, negative 6 and 7. B is 6 and 3. C is negative 4 and negative 3. Determine the coordinates of M, the midpoint of BC. The midpoint of BC. Okay. So if that's the midpoint, how do we calculate M? Using the midpoint formula, which is x1 plus x2 over 2, y1 plus y2 over 2. Okay? So this would be negative 4 plus 6 over 2 and negative 3 plus 3 over 2. So the coordinates of M would simply give you 1 and 0. Will you agree with that? What you should notice is also now that whenever I calculate something, I put it on the diagram. Okay? Make that a habit as well. Okay? B. Calculate the length of BA. They will give you an answer in simplest third form. So BA, how are you going to calculate BA? Using distance formula. Not so. So BA or AB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So that gives us negative 6 minus 6 squared plus 7 minus 3 squared. Click over here. There we go. That will give us the square root of 12 squared plus 4 squared. Gives us 4 root 10. Okay. You all okay with that? So it's 4 root 10. B, C. Calculate the gradient of AM. The gradient of AM, which is this line here. How do you calculate the gradient? Gradient of AM. And it'll be y2 minus y1 over x2 minus x1. For AM, we got the coordinates of A, we got the coordinates of A. So it's going to be minus 6. No. Y2 is going to be 7 minus 0 over minus 6 minus 1. Give an answer of negative 1. Now, you all agree with that? You all okay with that? Who's confused at this point? You all got those answers? Cheryl? You okay? Why are your pages loose? Where's your math book? In your bag?
So, I watched the video.
Of this? What's the video? Do the homework. You didn't do the homework. Oh, you did. Then you must take your book out of your bag and you must mark your homework. Huh? Alright, let's look at D. D says determine the equation of AM. So the equation of AM. What is AM? It's a? AM is a? It's a straight line. Not so. How do you calculate the equation? What would the standard form of the equation of straight line be? Y equals mx plus c. But what do we have at this point? Gradient. So y is equal to 1x plus c. So let's substitute the point that's lying on this graph. Negative 1. Okay, negative 1x, so negative x is. So you will substitute m, which is 1 and 0. Thank you. It's a x and a y. So 0 is equal to negative 1 times 1 plus c. So c is 1. So y is equal to negative x plus 1. Okay. E. Calculate M2. The angle M2, the inclination of AM. So M2 is this angle there. How do you calculate the inclination? I use tan of theta, which is M2 equals -1. Not so? So angle M2 is equal to arctan of -1, which is -45 degrees. Then what do I do then? We add 180, which is 135. Why does it sound like you guys didn't do the homework? Huh? We didn't? I didn't get that answer. You did? No, I don't talk to me. Huh? Then it says determine the inclination of BC. Give your answer correct to the nearest whole number. BC. When we look at BC, which is actually M1. Not so? You all agree with that? So we say that tan of theta, or tan of M1, is equal to the gradient of BC. Do we have the gradient of BC? Huh? No. So we must work out BC. How do you work out the gradient? Change in y by change in x. So it's going to be 3 minus -3 over 6 minus -4. It's going to give you 6 over 10, which is 3 over 5. That's all. So arctan of 3 over 5. Arctan of 3 over 5 is 31 degrees. Okay. Then the question says, is that it? Is there another question to this? Sorry? G. Okay, I didn't cut G, no? Says, determine the size of AMB. Okay, that's a question that many learners who are asked to do this exercise have a problem with. But AMB, the size of this angle, will be, there's no G, it will be AMB. It's going to be M2 minus M1. Can you see that? The size of that M2 minus the size of M1 will give you that angle that you're looking for. Oh, do you understand? Okay. So that would simply be 135 degrees minus 31 degrees, which gives you 104 degrees. Okay? Guys understand? Right, let's carry on with our lives. Number 2 you didn't have to do at this point. Number 3 was the next one you had to do, correct? So here in number 3 we are told P, which is -5 and -2, Q, which is 3 and 6, R, which is 4 and -3, are the vertices of triangle PQR. Okay. The question says prove that RQ is equal to RP. So how are you going to do this? What are they referring to then? Distance. So I must say for RQ, distance formula, which is x2 minus x1 squared, y2 minus y1 squared. So that gives us, so it's QR. Okay? So it's going to be 3 minus 4 squared plus 6 minus -3 squared. So that gives us the square root of 1 squared, or -1 squared, plus 9 squared. Gives you root of 82. Is that correct? Then RP, don't have to write the formula down again. So RP Again, it will be negative 5 minus 4 squared, which is 9 squared, and negative 2 minus 1, 3 squared is 1 squared, which is also the root of 82. Okay? So these are 9, 9, 1, 1. So therefore, RQ is equal to RP, which is equal to the root of 82. Right, you guys understand? So that is a root of 82 there, the root of 82. Then it says, give the coordinates of S, the midpoint of PQ. So there's S, the midpoint of PQ. So how do I do that? Midpoint formula. So x1 plus x2 over 2, y1 plus y2 over 2. Okay? So it's going to be negative 5 plus 3 over 2, negative 2 plus 6 over 2. So S will be 2 over 2, which is 1. Negative 2 plus 6 is 4, over 2 is 2. So S is going to be 1 and 2. Is that correct? Negative 1. Okay. You're absolutely correct. I made a mistake there. Without the negative. Okay? Any other confusion there? Wondering why you look so confused. Okay. Prove analytically. Again, if you're talking about analytical methods, you must use the formula that we're currently using here. To show that RS is perpendicular. RS is perpendicular to PQ. Okay. What does perpendicular mean? It is 90 degrees, not so. So, are we going to show that RS is perpendicular to PQ? I'm going to use the gradients, not so. So, the gradient of RS is equal to y2 minus y1 over x2 minus x1. So RS, RS, yeah. So it's going to be 2 minus minus 3 over minus 1 minus 4. This gives you 5 over negative 5, which is negative 1. Do you all agree with that? The gradient of negative 1. So if the gradient of PQ is 1, then the job is done. Not so. Because we know that the product of the two gradients must be negative 1. You see here they're asking you to prove that it's perpendicular. So I prove that by multiplying it together is minus 1. Later on they will tell you it is perpendicular. Then we can use the rule as it is. Okay? But if we must prove it, we must use the rule to prove it. Otherwise, if they say it is perpendicular, then I can use the fact that m1 times m2 is minus 1. Okay? So the gradient of QP is going to again be y2 minus y1 over x2 minus x1. So it's 6 minus minus 2 over 3 minus minus 5. So that's going to give you 8 over 8, which is 1. Not so. So we conclude, since we state the obvious, the gradient of RS times the gradient of QP is equal to negative 1 times 1, which is negative 1. Therefore, RS is perpendicular to QP. Okay, you must conclude it properly. No? You can't just say therefore it's perpendicular. No. You must conclude it like that to get your third mark, your fourth mark. So. Okay. D. D. We are asked to calculate the inclination of RS for 81 decimal place. No, the inclination of RS. So in other words, they want you to work out that angle there, not so. So let's call that theta for now, and I'll name it theta. So, tan of theta is equal to the gradient of RS. Not so. But what is the gradient of RS? It's negative 1, not so. Remember that gradient was 1. The gradient of RS is negative 1, so tan of theta is equal to negative 1. Arc tan of negative 1 is negative 45. Plus 180 is 150. Okay. E. Determine the equation of QP. What is QP? QP is a straight line, not so. So what is the equation of the straight line be? Y is equal to mx plus c. And what is m? 1. So it's 1x plus c. So how do I calculate c? I should substitute the point that's lying on QP. Okay? I can substitute this, I can substitute P, I can substitute Q. Okay, with Q, which is 3 and 6. Remembering that's an x and a. So 6 is equal to 1 times 3 plus c. So c works out to be 3. Y is equal to x plus. Figure that's correct? Huh? Yeah? So y is equal to x plus 3. That is E. Let's look at F. If the question says, give the coordinates of T, the x-intercept of PQ. How do you work out your x-intercept? X-intercept. Let y focus. Okay? So this is your y there. So 0 is equal to x plus 3. Remember, this is the equation of QP. So you take it over the equal sign, so x is equal to negative 3. So therefore, t would be negative 3 and 0. Okay? Any confusion there, people? They asked you to do number 5 as well, no? So in number 5, in exercise 4.6, we are on page 104 probably, or there. We are 105 is. We are told that E, which is negative 5, negative 15 and 0, F is negative 10, negative 5, G is 2 and 7, are the vertices of triangle EFG. Let's move this over. Let me go up. No? This is number 5. The first question says, determine the length of EF. Giving your answer in simplified third form. So how are you going to calculate the length of EF? Distance formula. Can you see the same formulas get used all the time? Just different diagrams. So the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's going to give you the square root of EF. So it's going to be those two coordinates. So it's negative 15 minus minus 10 squared plus 0 minus minus 5 squared. So that gives us the square root of 5 squared plus 5 squared, which is 5 root 2. Right. That's going to be 5 root. Look at B. B says give the equation of FG. So what is FG? The straight line. So the straight line will be in the form of y is equal to mx plus c. And I can calculate m, which is my gradient. y2 minus y1 over x2 minus x1. So it's 7 minus minus 5 and 2 minus minus 10. So that will be 12 over 12, which is 1. Yes? So you got y is equal to 1x plus c. We substitute the point that's lying on that graph. It can either be f or g. I'm going with g, which is 2 and 7. That's an x and a 1. So 7 is equal to 1 times 2 plus c. So c works out to be 5. So y is equal to x plus. Okay, any confusion there? We'll just flip it the other way. Okay. Any questions at this point? No? C. I can't take that away now. Unless okay. Right. The question says calculate angle D1. Now calculate angle D1. This is angle here. So what do I need in order to calculate D1? I need the gradient of FG. Not so. So D1 is, that angle is on that line. You will agree with that, people? You understand? Right. So, the gradient of FG, we change y, we change in x, so it's 7 minus minus 5 over 2 minus minus 10. Okay? So that's going to give you 12 over 12. No, we have the gradient. So you don't have to do this. So you say tan of D1 is equal to 1. And therefore D1 is equal to 45 degrees. Okay. Then it says prove that EF is perpendicular to FG. What do I do then? Sorry? Gradients. So the gradient of EF. The gradient of EF. How do we do that? Y2 minus Y1 over X2 minus X1. So it's 0 minus minus 5 over minus 15 minus minus 10. So it gives you 5 over 5. 5 over negative 5, which is negative 1. Not so. But the gradient of if G, we know already. What is that? 1. So we say since the gradient of EF times the gradient of FG equals 1 times negative 1, which is negative 1. Therefore, EF is perpendicular to FG. So what I do is I immediately put 90 degrees. Okay. You guys understand? Then, I want you to calculate the size of angle E1. Okay. There's many ways of calculating E1. But what do we have here? We have 45, so D2 is also 45. Not so? So D2 is 45 degrees. Why? This is vertically opposite. Do I need to state this here? No, we're not busy with Euclidean. Okay, unless the question says with reason. Okay? Which it didn't. So that is 45 degrees. So are we going to calculate E1? Sum of triangles. So E1 is equal to 180 minus 90 minus 45. Again, we don't have to say this sum of triangles, it's triangle EDF, which gives you 45. Otherwise, what you could have done was, Another way of calculating that angle there. I could have extended this line here, FE. And I work out this angle of inclination. As the gradient is -1, so that angle of inclination will be 135 degrees. So how would I work this one out? Angles on a straight line, which will result in 45 degrees. Okay? Either way, you'll get the full mark for that question. Okay? So the last question, for number 5. Let's look at number 7. Nope, it's the last question. Okay. So for homework, I would like you guys to do even numbers of exercise 4.6. Even numbers of exercise 4.6. And we start with number 2. Okay. I don't know if there will be time left. I don't think there will be time left to do this, but I will pause the video so long, maybe there is time left, okay? So I'll give you a couple of minutes to sort out number 2. Alright, so let's answer these questions quickly. Number 2, we are told that P, which is -5 and 7Q, which is 6 and 4, R, 4 and -2, S, which is -8 and -4, are vertices of quadrilateral PQRs. The question says, prove that PS is perpendicular to PS is perpendicular to PQ. So what do we need to do here? Gradient. So PS, the gradient is y2 minus y1 over x2 minus x1. You could have used Pythagoras here, but it's quite a long calculation in order to do that. Okay. So then you prove the converse of the theorem of Pythagoras. Okay. So if you're going with PS, it's going to be 7 minus 4 over -5 minus -8. So that's going to give us 11 over 3. Is that correct? Then the gradient of PQ. If the gradient of PQ is -3 over 11, I've done the job. Okay, so PQ is going to be 4 minus 7 over 6 minus -5. So that's going to give you -3 over 11. Not so. So we say since the gradient of PS times the gradient of PQ is equal to 11 over 3 times -3 over 11, which is -1. Therefore, PS is perpendicular to PQ. So PS is 11 over 3 and PQ is -3 over 11, which means to say that is 90 degrees. Not so. Look at B. The B part of the question says determine the equation of PR. So the equation of PR will be in the form of y is equal to mx plus c. So PR is this line going through here. You all agree with that? So what do I need to do for work out there? I need to work out my gradient as well. Not so. The gradient of PR, again changing y by changing x, is 7 minus -2 over -5 minus 4, which is 9 over -9, which is -1. Not so. So the equation of this line is y is equal to -x plus c. How do you calculate c? I substitute one of the points that lying on this line. So we're going to substitute r, which is 4 and -2. Remembering that's a x and a y. -2 is equal to -4 plus c, so c is 2. Y is equal to -x plus 2. Okay. You all still with me? Alright. Nobody sleeping today? Okay. So it's early in the morning now, no? Second period of the day. You see? Calculate the coordinates of S, the y-intercept of PR. That's supposed to have been S there. Okay, but there's already an S. I think in the textbooks there's a K, no? Or something. Huh? Yes, there's a K. So, This is the older version, okay. People, so how do I calculate your y-intercept? Y-intercept left, x equal to 0. Okay, so we got the equation of PR. So I'm going with that there. So y is equal to negative 0 plus 2, which is 2. So therefore S is 0 and 2. Jesus. Okay. You all okay with that? Any confusion? No? The next question is E. Determine the size of P1 correct to 1 decimal place. P1. Now, if you're looking at P1, definitely I can't work out that using the gradients straight away. No? However, I can use, by using gradients, I can work out T1 and I can work out the size of V1. Not so? Then I can say the exterior angle is equal to the sum of the two interior opposites. Does it make sense? So E, we know that tan of angle T1 is equal to the gradient of PR. Gradient of PR is negative 1. So arctan of negative 1 is going to be negative 45 plus 180 gives you 135. For V1, so I say tan of V1 is equal to the gradient of PS. We know what the gradient of PS is. It's 11 over 3. So V1 is equal to arctan of 11 over 3. So arctan of 11 over 3 gives us 74,74. But have I answered the question? No. So angle P1 is equal to T1 minus V1. The reason is the exterior angle of triangle. No? So that's simply going to be 135 minus 74,74. Is 60,3. Is that correct? Okay. So for homework is number 4 and 6, no? And then for Monday is the hand in the sun, which is the revision exercise. We are going to do 4 and 6 with the questions that we'll have from 4 and 6. We're going to do that with the revision exercise in one lesson. Okay. People enjoy the rest of your day. Good morning, class.